Okay, now, last time we had figured out the CFFA and we had used the NPV function in Excel to calculate this thing. But there was one problem with the NPV function. Does anyone remember what it is? Say again?
I said yes, I do remember.
You do remember. What is it?
You have to do something funky.
You have to do something
You have to
funky.
leave out the first, you start at year one and then add back the end or something.
Very good.
See, I told you.
Excellent. Okay, so did you hear that? So NPV function just gives you present value at time 0 starting at time 1. And then you have to add that first cash flow, which has already got a negative sign on it, and that'll give you true NPV. So that's the funkiness. Now, something you should always do after you build a spreadsheet is check your work using your calculator. So let's pull up the calculator. CF, second, clear work. What should I put in for CF0? Yeah, 260,000. Negative, enter, arrow down. 39,800 for time 1. Enter, arrow down, arrow down. 54,192. Enter, arrow down, arrow down. 66,845.76. Come on. 76. Enter. Arrow down, arrow down. 59,895.696. Enter. Arrow down, arrow down. C05 is 224,649.6271. And of course, you don't have to put all that in there, but we're just trying to make sure we've got it right. Enter. Now I'm going to hit NPV. In order to get this number right here, what should I put in for I? 4. Enter. Arrow down. Compute. And I'm getting roughly the same number. It's actually less than a penny's difference, right? In fact, if we went down here and went out bigger on our decimals, you can see it's pretty much the same number. Why is it not exactly? Because it's a different number of places. Now, if we got into different situations, we might find that we'd be a little bit off because of that rounding that we did, because these things are not dollars and cents. You can see that they stick out further than that. Okay, now, what's something else that I can find while I have those cash flows in my calculator? Internal rate of return, so I'm going to hit IRR, compute. And it's telling me 15.677. And if you think back to the project, I didn't bring my copy with me today, but they show 15.67% being an NPV of 0. What's the definition of IRR? Yeah, it's a discount rate that makes NPV equal to 0. And so in their minds, that is the IRR. But if we put in 15.67 here, we get $56.72. There's two reasons for that. Number one, we didn't round on our prices and costs the way they did. And number two is that reported value in the table is undoubtedly rounded, right? It's like 15.6, it's got some error in it. And so that's why this is slightly off. If I wanted to find out what the IRR was here, it's easy enough. IRR, and all I do is say equal IRR, open parentheses, and I grab all those. It's intuitive. You just grab them all, and there you go. Now, let's pull that on back, and we get the same number we got from our calculator. And to demonstrate that that is the IRR, I'm going to say equal to, boom, down here. And there we go. So you can find IRR really easily on both your calculator and on Excel if you've already done your NPV. There is never any reason not to do both. Questions? Actually, I shouldn't say there's never any reason, because there are two things that make IRR suck. What are they? This is going to be on the exam, by the way. Mutually exclusive projects and, yeah, the unconventional cash flows. And so if you had unconventional cash flows, you would not go ahead and calculate IRR. If you were doing NPV for 2 mutually exclusive projects, you would not do IRR. Questions? Okay, now we had talked something about seeing those inflection points for the IRR where it crossed NPV, and that's going to take some time, and you have expressed some interest in doing more review and less maybe some fun stuff. So if you don't mind, I'll skip that and we'll move on from there. If you really want to see it come by in my office hours, I'll show it to you. Okay, so this is what we wanted to learn from this project. By the way, if I have a rate of 15%, do I accept the project according to the rule? Yeah, positive, right? If I have a rate of 17%, do I accept or reject? Reject it. Okay, I'm going to go ahead and save that, and we'll be done with it. Any questions before I kill it off? Okay, let's get back to our PowerPoint slides. And we're going to talk about inflation and capital budgeting. So if you think back to, hopefully they taught you this in 380 and 390, the relationship between real return and nominal return. Real return is all about how much can I increase my consumption as a result of having made this investment. Nominal return is all about how many units of currency am I going to receive back for having made this investment. If inflation's 0, they're exactly the same. But inflation, even in normal times, is hardly ever 0. So here is our equation. This is known as the Fisher effect. This is known as the Fisher effect. And that R is our nominal return. The little r is real. And H is inflation. Any idea why we use H for inflation? Why wouldn't we use I? Interest and some other stuff that starts with I. So we use H. Now, what does Dr. Whitty, I think, uses pi for inflation? Have you guys seen him use it? Yeah. And you know what happens on exams? Students will put in 3.14. Yeah. So that's why I don't use pi for inflation, right? We're gonna use H. Okay. Now, the thing you need to know about capital budgeting is that as long as we discount nominal cash flows with nominal rate, we're going to get exactly the same answer that we're going to get from discounting real cash flows at the real rate. And I'll show you why that is. So let's say, bless you,
Thank you.
big FV is nominal, and little FV is real. I think that's good enough. So here we go. If we're doing present values, we know it's future value divided by, and it's 1 plus r to the t. So we've got the future value in nominal terms, and we've got the nominal rate down here. Now, if I were to blow that out to show the impact of inflation using the Fisher effect, it would look like this. It would be equal to the real future value times 1 plus h to the t. And why is that? It's because inflation compounds just like interest. And so that's going to be your nominal to real, or real to nominal conversions. You're going to multiply by 1 plus h to the t. Now, what about the bottom part? Well, we know that 1 plus r to the t is going to be equal to 1 plus r to the t times 1 plus h to the t. I haven't broken any laws there as far as I know, mathematical laws. Now, once I get that up there, what do you notice? What cancels out? Yeah, the 1 plus h to the t, these things cancel out. And so these end up being exactly the same. And so for every one of those future cash flows, the present value is the same if you take a nominal discounted at a nominal rate or real discounted at the real rate. Now you say, wait a minute, that doesn't say anything about the time zero cash flow. Does inflation impact the time zero cash flow? Not in the least. And so that's why we're not concerned about that. So, long story short, if you have, oh, by the way, the numbers that we see out in the market, are they real or nominal? Yeah, they're nominal. When I loan you money, not only am I going to be asking you for the real return, I'm going to be throwing in my expectation of inflation there, because I definitely want to get more money back at the end in real terms than I did in the beginning. The only way to do that is to account for inflation. Right now, my mortgage has a negative real rate of return for whoever the poor sucker was that loaned me that money. Why is that? Because my mortgage at 3.375% is actually less than the rate of inflation. The money I'm paying them back is worth less than the money that they loaned me. And my mom wonders why I don't pay off my mortgage. It's making me money, right? Okay. Let's see. Oh, so if you've got a project and you've got the nominal rate of return and you've got all nominal cash flows except for one real cash flow. And so we've got 29 different numbers here. 28 of them are nominal. One of them is real. Do I convert the one real to nominal or the 28 nominal to real? Yeah, you just convert the one, right? And there's two reasons to do that. Number one, I am lazy. I've already told you that. And number two, how many opportunities do you have to screw up with converting one? You've got one. How many opportunities to screw up do you have with converting 28? You got 28. Are you going to screw up at some point? Yes. Okay, so that's what I would tell you about inflation and capital budgeting. Now let's go on and talk about investments of unequal lives. So we are going to make the assumption that we're looking at two machines. And these machines do exactly the same thing. They do exactly the same thing. Now they cost different amounts and they live for different amounts of time. So my example here is in 1995 I bought a Honda Civic. And 1997 came around and we had just bought a house, so we were basically flat broke. And my wife's Chevy Cavalier died as a result of my mechanical malpractice on it. And so I had to get her a new car. And so I went and we looked at Honda Civics because she liked mine, but they were a little pricey compared to the Plymouth Neon. And so what did we do? We ended up buying a Plymouth Neon, and it only lasted, say, 50,000 miles. Just a total piece of junk. Different lives between the Neon and the Civic. I ended up driving that Civic for 7 years, 8 years, and I put like 150,000 miles on it. Just freaking great car. Cost me very little. So we're going to, what this is all about is looking at these sorts of situations and trying to figure out which one of these do we get. And the answer is we take these costs. By the way, we're just looking at costs because remember, we assume they do the same thing. And so what we're going to do is find the present value of all the costs associated with these things. We're going to bring it back to time zero. If they had the same life, all I would have to do then is compare those two numbers and take the one with the lower present value of cost. But when they've got different lives, you can't do that. So step 2 would be to take those present values and blow them back out to the length of the life for each one of these and look at an equivalent annual cost, also called an effective annual cost. If we take this and we find an annuity that has the same present value as the machine, the payment that we compute is going to be the effective annual cost. And so it'll be, it'll have the same present value, but now we have put this thing on a year basis. Well, Now, all we have to do is compare the two effective or equivalent annual costs. Which do you think you would prefer? A higher equivalent annual cost or a lower equivalent annual cost? Yeah, we all prefer a lower cost, right? Okay, so let's do an example. So what we have here are two tennis ball throwing machines down at the country club, because even some people who are rich still don't have friends, and they need the tennis ball throwing machine to help them practice. And we've got two machines we've got our eyes on. Machine A costs $500 to start, and then it's going to live 3 years. And in each of those 3 years, we'll have to spend $120 on maintenance. Now, notice the sign is the same for all of these. The sign is the same for all of these. And the reason for that is they are all expenses. They are all expenses. And the signs should all be the same for them. Now, sometimes students will say, well, wait a minute, shouldn't they all be negative? I'm like, yeah, fine. But keep in mind, that's going to cost you extra keystrokes and you might screw up. And so I just prefer to leave them positive. Okay, now machine B has an initial cost of $600, and then it costs $100 per year, and it lasts 4 years. Now, if you look at this right now with no more information, there's really not any way for you to know which one to select. In fact, I have to give you the required rate of return before you can know which one to select. And I'm going to tell you this. What happens to the present value of the future cash flows as that required rate goes up? What happens to the present value as the required rate goes up? Yeah, it goes down. And so at some point, that rate is going to go so high that those future cash flows are less important to the NPV than the initial cash flow. I can find a rate of return high enough that will make A the choice. The question is 10% that number? By the way, 10% is our required return for this project. So, first thing we're going to do, we're going to go to our calculator, and we're going to say CF, second, clear work. And then we are, for example A, we're going to put in 500, enter, arrow down. What's C01? 120. Enter, arrow down. What is F01? 3. Okay, now we are going to find the present value of all those cash flows. And the way I do that is with the NPV key. What do I put in for R? 10. Enter, arrow down, compute. I'm getting $798.42. What does that represent? It is the present value of all the expense associated with that item. And so that's what we are going to treat as our present value for purposes of finding our annuity payment or equivalent annual cost. I'm really paranoid, so here's what I'm going to do. I'm going to say store in location 1, just in case things go terribly wrong. I'll still have that number. And then I'm going to hit clear twice. Now we are going to use the time value of money keys to find payment, which is going to be our equivalent annual cost. But what do I always do before I use the time value money keys? Yeah, second, FV to clear TVM. What button should I hit next? PV. That thing is the present value that we're going to try to blow out over the life. By the way, what is the life of machine A? 3. And I think, oh, what do we got to put in for I? 10. Yeah, 10 for I over Y. And now we're ready to compute the payment. And so the equivalent annual cost for machine A is $321.06. Okay. What does this mean? It means that at 10%, the present value of 500, 120, 120, 120 is exactly the same as the present value of 0, 32106, 32106, 32106. And so that payment that we calculate is our equivalent annual cost. Okay, now we got to do letter B here, project B. We're going to hit CF second, clear work. What is CF0 for project B? 600. Enter, arrow down. What's C01? 100. Enter, arrow down. What's F01? 4. Enter. What button do I hit next? NPV. And what do I put in for I? 10. Enter. Arrow down. Compute. I'm getting $916.99. If you're not getting the same numbers, please let me know. Okay, now, what do you think I'm going to do next? Because I'm paranoid, I'm going to store 2. And then I'm going to hit clear twice. And then what do I do before I use the TVM keys? Second, clear TVM. And I'm going to put this in as present value. In this case, what is N? 4, very good. And what is I per Y? 10. Enter I per Y. Now we're ready to compute the payment. The equivalent annual cost of B is equal to $289.28. Which would we choose? Yeah, think about it. Would you rather rent an apartment with a rent of $289.28 or $321.06, assuming they were otherwise identical? You'd want to go with the $289.28. I once lived in an apartment or actually it was half of a duplex. The rent was $100 a month and the locks on the doors did not work. And there was a cat that lived there that none of us knew. So anytime you get to feeling bad about whatever squalid hellhole you're living in, just come by and we can talk about finding a cat in your bed that you have no idea who it is, right? It shows up. Okay, so $289.28 is better than $321.06. Questions? Yes?
So you know it's lower, you're still paying for longer. So how does that?
Okay, so here's what we did. Because we took all the costs and squished them back to time 0. And then we blew it back out. Basically what we're doing is assuming that when we get done with the 3-year life, we'll replace it with a like machine.
Okay.
And with the 4-year life, we make the assumption that we're replacing it with a like machine. So that means basically every year forevermore, the assumption is that machine A will cost us $321.06 every year, and machine B will cost us $289.28 per year. If you didn't think you were replacing the machine, the math might be different, but that's always our assumption. It's an implicit assumption that we're going to end up replacing this machine with a like machine. Good question. Other questions? Okay. By the way, this one usually gives students problems, and the biggest problem is that they want to put a negative sign on CF0. Don't do it. Don't give in to the temptation. So now we're on to the general decision to replace. And it is the most common capital budgeting decision that we make. And here's why. Stuff wears out. Machines wear out. And we have to replace them. And what happens as a machine gets older? It requires more and more maintenance, and that costs more and more money. And so it's those maintenance costs, or the avoidance thereof, that is going to allow us to justify buying a new machine. I'll give you an example. I had this Nissan Sentra 2001 model. I loved that car. And in the beginning, there were a few teething problems, but then they were taken care of under warranty. After that, I would give her gasoline and oil changes, and she gave me nothing but love in return. And then when she gets to be about 6-7 years old, she starts to have a little problem, but it's not a big deal. I fix it. But over time, the problems just got bigger and bigger and bigger. And so that extra maintenance cost gets you to thinking, wait a minute, is it time for me to replace the car? And machines are exactly the same way. Machines in the factory, they start to wear out, and then eventually they get to where it's actually cheaper to buy a new machine than to keep nursemaiding the old one. Now, new machines are going to have a lower maintenance cost going forward, but they're going to cost more up front. So we're going to have to balance these things out. Now, our assumption here is that these machines are equally productive. What does equally productive mean?
Production.
Yeah, they could make the same stuff, right? The same stuff at the same rate. In other words, the outcome, the output of these machines is identical. In the real world, let me tell you, this is not true. That's worst case scenario. But every time that I've bought and analyzed a new machine, it was always more productive than the last one thanks to advances in technology. And so that's an assumption we're making that may not be necessarily true. How are we going to do this? What we are going to do is look at the equivalent annual cost of the new machine. Sorry, the equivalent annual cost of the new machine. And then that's going to be our benchmark. And the first year in which the cost of the old machine, in which keeping it one more year is going to cost us more than the equivalent annual cost, then we go ahead and replace it. So that's the rule. The first year in which the cost to hold on to the old machine for one more year exceeds the equivalent annual cost, then we go ahead and get the new machine. So let's look here at an example. We have two machines. The first bullet point is the new machine, the replacement machine. It's going to cost us $9,000. It's going to cost us $1,000 per year in maintenance. It's going to have a life of 8 years, and at the end, it'll have a salvage value of $2,000. So we need to figure the equivalent annual cost of this new machine. Where should I start? What's the first button I should hit? CF? Second? Clear work. Please turn that off, whoever's getting, was that Amber Alert?
My alarm.
It's your alarm. Why do students set alarms to go off in the middle of class?
Just in case I'm sleeping.
Well, perhaps you should set it before, and that way you could be here on time if you were napping. Oh, you mean fall asleep in class?
No,
Oh, okay.
not necessarily.
Okay, not necessarily, okay. So, what's CF0 here? Cost $9,000 up front, right? Enter, arrow down. What's C01? 1,000, very good. Enter, arrow down. What's F01? Everybody wants to say 8, but it's actually 7. Can you tell me why? What's different about that last cash flow?
Get the salary value.
Yeah, you get the salvage value back at the end, so that cash flow is different. So we're going to have a C02 here. Now, in that last year, we spend $1,000 on maintenance, but we receive back $2,000. So we're looking at $1,000 cash going out, $2,000 cash going back in. These numbers are all spending numbers, so that maintenance number is positive 1,000. Subtract 2,000 for the money coming back to you, makes this last cash flow minus 1,000. Now, every time after I give this talk, someone comes up at the end and says, "Can you explain to me again what's up with the last cash flow there?" Let me go through it one more time. We have cash flow 0 where we buy the machine. And then we have the next 7 years, which are all identical. Why is the last one different? Because we are getting money back. And so we've got that 1,000 that's going out for maintenance in that last year, but then we also get $2,000 back. 1,000 minus 2,000 is minus 1,000. Any questions?
Did you put 9,000 at the beginning negative?
Ah, very good.
I missed that.
Okay, she's asking, did we put 9,000 at the
She
beginning
said not to
negative?
do that.
No.
Okay.
Did I do it? Let's find out. No. So it's positive because it's an expense. So is so are the next 7. And then the last one is minus 1,000 because net you've got $1,000 coming back. Okay, and then of course C0 or F02 is 1 because that only happens once. So what would I do next in my quest to get the equivalent annual cost of this machine? Yeah, I'm going to hit NPV, and they tell us the required return is 15%, so I'm going to say 15, enter, arrow down, compute. I'm getting $12,833.52. Is that what you guys are getting? Okay, so I'm going to, because I'm paranoid, I'm going to hit store 1. And now I'm going to hit clear twice. What is the next step for me to find equivalent or effective annual cost? Yeah, second, clear TVM. And then what button do I hit? PV. Now, what is the life of this machine? 8. We put in 8 for N. Sometimes students want to put in 7 because we had that discussion earlier. No, it's the life of the machine that you're putting this out over. 15 for I per Y. And then I'm ready to compute the payment. And so my equivalent annual cost of the new machine is equal to $2,859.95. And so any year in which it will be cheaper to spend this money than to keep the old machine alive for another year, then we will go ahead and replace it at the beginning of that year. So now we need to go look at the old machine. By the way, where do you think the numbers for the new machine come from? The people that sell you the machine, first of all, you're going to know the price, right? As far as that annual maintenance goes, perhaps they offer a maintenance contract, and so you can lock those numbers in advance. If not, they can help you estimate what's going to need to be done, and you can look at number of hours and things like that. Now, the other one is a little more difficult because that machine's been sitting in our shop for a long time, and it's today it's worth $4,000. But notice if I wait a year, it's worth less. Any idea why? If you were going to go buy a used car right now, and you had otherwise identical used cars, would you prefer a 2016 or a 2015? Yeah, the 16, right? You'd rather have the newer machine. And so the value of these things is going to fall. And by the way, one of the big reasons the value is going to fall is because each year they require more and more maintenance. Let's talk about where these numbers come from. If you get out into the work world and you are working for a organization of any size, they're going to have a maintenance department, and that maintenance department will track the maintenance costs per machine or server or whatever it is that you're working on. And so they're going to have historical data, and they can use that data and see if there is a trend in it, and that would help you come up with numbers like these. But the trend by itself is not enough, because sometimes there are big maintenance things that come up. After, let's take airliners for example. If you've got an airliner in years 1 through 6, your maintenance is going to be trending pretty much like this. But then at the end of year 6, you are required to completely strip that airplane down to the rivets, complete a thorough inspection and then basically reinstall everything. I know this blows minds, but it's not only true in the US, it's also true in China. I had a guy in my class from the Chinese Aviation Administration, something or other. Anyway, do you think that the maintenance cost is going to be much higher in that year? Absolutely. And so it's good to know about these things. Now, an actual example from my practice, I had a bunch of machines and I was trying to come up with my maintenance budget for the year with my maintenance director, Tom. And I asked him, what's going on with 237 next year? He says, well, basically all your machines are going to be just trending upward, and I'll give you the percentage. He said, but 237 is a special case. And I said, why is 237 a special case? He says, because you're going to need to replace the thrust bearing next year. I said, how do you know we're going to need, are you psychic? He said, no. He said, they're only good for 5,000 hours, and your machine is going to be crossing that 5,000 hour mark next year, so we're going to have to replace the thrust bearing. I said, okay, how much is that going to cost me? He said, 30,000 bucks. Okay, so now I've got more money that I can throw into my analysis, or my budget in my case. So that's the first place you can get maintenance cost numbers, is from maintenance people. But let's ask this question, and I want you to think very carefully about it. What kind of machines do you think maintenance people prefer? Old machines or new machines? Everybody wants to say new, but the truth is maintenance people get paid by the hour, so they prefer old machines because old machines require more work. Does that make sense? Remember, people are scumbags. When are maintenance people most likely to report a problem? 4:30 on Friday afternoon. Why? Overtime, right? If they found this problem at 8:30 on Monday, we would have solved it on straight time. But since they found it on Friday at 4:30, oh, guess what, guys? Woo, we're in here making 50% extra per hour to fix this problem. You think I'm kidding? I'm not. I used to work in a nuclear power plant, and the operators, the mechanics, those are the two big groups. Operators and mechanics were hourly. I was an engineer. Do you think I was working by the hour? No, I'm on a monthly. But when you're in the plant, by the way, it was ran by an old submarine commander. Most of the nuclear power stations in the United States are ran by former Navy people, if you didn't know that. And this guy, his name was Buzz Carnes. And when one of these things would happen, we would get the announcement, all hands on deck. What does that mean? It means if you're still here, you're supposed to gather and fix this problem. Well, that's great news to the maintenance people and to the operators. But what about for those of us on a monthly salary? That was a big pain in the butt. There we're stuck, our Friday night's ruined, and we're not getting anything for it. So, what was the solution to the problem? By the way, do you think they needed all those engineers to stand around while this problem got fixed? Absolutely not. So the problem, what they did, and they made a big mistake here, they allowed us to flex our hours. And so what we all started doing was working 7 to 4 on Fridays instead of 8 to 5. No more problems for me, man. Right? Okay, so maintenance people will underestimate future maintenance costs to help prevent you from replacing the machine. Now, there's another group of people who could give you this information, and they are called engineers, because they can get the data from your maintenance department, they can read the manuals, they can know what needs to be done at 5,000 hours, things like that. And engineers will provide you a different, I guarantee you the numbers will be different. Here's why. Do engineers like new machines or old machines? New! Oh man, there's nothing like new machine smell. You know how new car smell is? Well, imagine that for engineers, this new machine smell. It smells like machine oil. There's no filthy, rotten sock smell to it yet. I mean, it's just really great. So we love putting in these new machines. It keeps us busy, keeps us off the streets, keeps us out of the bars. And it's exciting stuff, right? And so what are our engineers going to do with these projected maintenance costs? they're going to overestimate projected maintenance costs on the old machine to try to hurry along this process of replacing the machine. And so we've got two different groups of liars here. We've got pessimists and optimists, we'll call them. What should I do with those two sets of numbers? Average them. Average them. Now we've got the best swag that we can get, right? Okay, so that's where we get the maintenance numbers. Where do we get the salvage numbers? Well, back when I started doing this, we did not have the internet like we have it today. It was pretty much non-existent. And so where would we go to try to figure out what machinery was worth? We would go to our machine dealer. And the machine dealer I worked with, I thought his name was kind of fun for this job. His name was Rusty, because his old machines, Rusty, makes sense. And Rusty would come in, and here's how this would work. I would say, Rusty, I'm thinking about selling this lathe. By the way, a lathe is a machine that makes round things. And I said, how much would you give me for it? And here's what Rusty does. He comes up to it, and first of all, he blows off the chips with the air, compressed air, and then he starts running the wheels back and forth. This is a manual machine, running the wheels back and forth. He's looking for slop, looking for wear, and then he smells it. You can learn a lot by smelling a machine, because if it smells like something's burning, there's probably an electrical problem. If it smells rotten, that's pretty normal for a machine shop. But he's going to, after all that, he's going to tell me, well, I'd give you $4,000 for it today. That is an entirely good number, because the man literally would write me a check today. By the way, remember the definition of a dealer: holds an inventory and stands ready to buy or sell. Well, right now he's putting out his bid price for that machine. Now, when he turns around to sell it, it's going to be basically his ask price, right? Okay, so I say, okay, what if I kept it for another year, running it 2 shifts a day, 5 days a week, cutting aluminum? And I have to tell him I'm cutting aluminum because that's easier on the machine than cutting steel. And he says, well, he says it's a guess, but about $2,500. So there's my time one salvage value. And then I ask him, well, what if I held on to it for 2 more years? Now he starts to get a little irritated with me, because seeing that far into the future is difficult, right? What's the most accurate number up here? 4,000. What's the next most accurate? 2,500. And then it just gets worse from there, right? And so by the time we get down to year 4, he says, I wouldn't give you a damn thing for it. And we're done, right? Okay, so that's where I get those kinds of numbers back in the old days. Here's what you would do today. You would go out and you would look for a machine the same age as yours. And you would take about 80% of that number. You got to figure out what the dealer's getting out of this, right? You got to take, because that's an ask price that you're saying. What you would want is the bid. And so you can multiply by, say, 0.8 and come up with what the dealer would be willing to pay you. And that would be your time 0. To find time 1, you find a machine that is 1 year older than yours and do the same thing. And for time 2, you find a machine that's 2 years older than yours and do the same thing. A lot of people in factories assume that the machines that they have are just identical or are just special, unique to them. They're not. They put those machines in a lot of different factories, and so there are a lot of them out there available for sale. Okay, so those are the 2 ways you could come up with salvage value. So now let's talk about the process we go through to figure out the cost to hold on to these things for an additional year. If I'm going to hold on to this from time 0 to time 1, how much is it going to cost me in maintenance? Say again? 1,000. Very good. But then we have a salvage value at the end of the year. It's $2,500. So the sign on that is minus. That's money back to me. So far, it's looking like I'm gonna make money by holding on to it for 1 more year, except for one thing. What did I have to give up at time zero to be able to hold on to the machine for one more year? Okay, he's saying $1,500 in salvage value, but I'm going to argue that it's actually more than that. Because what we gave up at time zero, we gave up $4,000 of cash we could have gotten then, but what could we have done with that cash? Invested it at our required rate of return, and so we're going to multiply that by 1.15 because R is 15. And so that makes this number here 4,600. That's the future value of that 4,000. And so now when I put all these numbers together, 1,000 plus 4,600 is 5,600 minus 2,500 is plus $3,100. What was our decision point for whether or not to replace the machine? Yeah. If it exceeds the equivalent annual cost of the new machine, then we go ahead and replace it. The equivalent annual cost of the new machine is $2,859.95. Did we exceed that number already? Yeah. And so the answer here would be to go ahead and replace it at time zero. Replace it at time zero because holding it to time one is more expensive than going ahead and replacing it. Now, just for fun, let's assume that we didn't quite make it there at time zero. What would we need to do with the next time? Well, we would say, well, how much maintenance is there going to be at time two?
2,000?
Yeah, 2,000. And how much would we get for selling the machine at the end of that year? How much?
Maybe 1,500.
Once again. And what did we have to give up in order to get there? To hold it from time one to time two. So actually we had to give up 2,500 times 1.15. Does that make sense? Okay. So be careful subtracting one salvage value from another because there's time value of money between them. Okay, so what is 2,500 times 1.15?
2875?
2875. And so we've got 2875 plus 2,000 minus 1,500, I think, gives us 3,375.
Yeah.
And so that number is greater than the equivalent annual cost of the new machine. So here's where the textbook and I differ. The textbook says you keep doing this exercise until you find the first year in which, and let's say it's 3. Year 3 is the first year in which it's going to be more expensive to hold on to the old machine than to have the new machine. And what the book basically says is once you figure that out, you just, basically set yourself a reminder that 3 years you need to replace the machine. That's crap. Let me tell you the way that I would go about this if I were you. First of all, I'm not going to go out there and gather years 2, 3, and 4. And the reason I'm not going to do that is, number one, it requires a lot of work. And number two, we know that the further out in time you go, the worse the future prediction is, right? The worse the forecast is. And so what I'm going to do is I'm only going to get time 0 and time 1. And I'm going to get a quote for the new machine. And if it doesn't make sense to replace it now, what I'm going to do is I'm going to set in my phone a reminder, re-examine machine 237. And I'm going to look at them every year. And I'm only going to look at year 0 and year 1. And the reason I'm going to do that is two things. Number one, the replacement machine, that equivalent annual cost for the replacement machine might change year to year. For example, if you're doing something that is benefiting from technology improving, then the cost of that replacement machine will go down. For example, 3D printers. I don't know if you've ever messed with these things, but in the beginning those things cost several $1,000s a piece. And they couldn't do all that much. Recently I bought one for $699, it'll do any darn thing I want it to. And so technology brings those prices down. Of course, you could have inflation driving them up. The only way to know for sure is to get a fresh quote every year. Now, the other thing with salvage value is things can actually impact salvage value that you wouldn't even think about. So getting back to when I offered up that lathe to Rusty, what you need to know about the lathe is it was a lathe for making big stuff. And I offered up this lathe to Rusty because I didn't really have use for it. It was sitting in my shop. I thought I could get some money out of it. And Rusty offered me $50,000 for the machine. And I'm like, woohoo, I like that. And he says, I can write you a check right now. I says, no, so let me think about it. In the meantime, while I'm thinking about it, let's see, Exxon. Exxon makes a discovery off the west coast of Australia, and they are going to be doing something really weird to get that oil out of the ground. They're going to be drilling holes larger than any oil well ever drilled before. There was something special about that reservoir that needed big holes. And so that means that the stuff that I made that goes into the hole has to also be larger. And so suddenly that lathe that I was getting ready to sell becomes valuable. And I'm talking to my planner, the guy that plans the work going through the shop. He says, bro, we actually need 2 of those. We need 2. And so I call up Rusty and I say, hey, Rusty, you know that machine that I had you come look at? He's like, yeah. And I said, he says, are you interested in selling? I said, no, in fact, I'd like to get another one. He says, He said, let me guess, you're working on that Western Australia deal. I said, yeah. He says, so's everybody else. I said, okay, what's it going to cost me to get a lathe? He said, if you're lucky enough for me able to find one for you, it'll be at least $100,000. Look what happened to the value. The salvage value there just went up by a factor of 2 because of a new demand in the market. And that's another reason not to go ahead and plan things out like this, like they tell us to in the book, because salvage values can change. Does that make sense? Okay. I believe that's the end of chapter 8. So now we are ready to talk about any questions you want to talk about. So we have our normal, we've got 20 minutes here, folks. Chapters 12, 7, and 8. And we have practice and homework.
Practice 5, or I mean 6.
Okay, 12, practice
5,
6.
sorry.
5?
Yeah.
Just jacking with me.
Wait, I have a
Okay, next. 12 homeworks.
Oh, number 2, 7, and 8 for chapter 12 practice.
Okay. Others?
9 on 12 practice.
Looks like we're going to spend a lot of time. We're going to spend all of our time on chapter 12. Was there anything from 7 or 8 that anyone's just dying to know?
Number 7 homework.
On number chapter 8,
Homework.
Oh. Number 10? Okay. What else?
Number 3 on chapter 8 practice. I don't know, but we don't have time for that.
Okay.
That's 22, 23, and 24 from chapter 8 practice.
Yeah, that's what we just did.
Okay. I think we've got plenty here, so let's get started. So the first thing we're going to do is go to chapter 12, practice. Good. Keep in mind these are algorithmics, so my numbers will be a little different than yours, but it's the same underlying problem. Okay, Farmers Lamas has an weighted average cost of capital of 10.7%. The company's cost of equity is 12%, and its cost of debt, pre-tax cost of debt is 7.8%, tax rate is 22%. What's the company's debt to equity ratio? Okay, so here's what I'm going to show you on this one. The weight on the debt for that formula is equal to TD over TA, total debt over total assets. Can we agree on that? That's the weight. The weight on the equity is equal to total equity over total assets. Can we agree on that one? What happens when I take the weight on debt divided by the weight on equity? I get TD divided by TA over TE divided by TA. What happens to the TAs? They cancel out. And what does that mean? It means that the ratio of those two weights is your debt to equity ratio. Now, they have given us information to be able to figure out actually, let's just put it up here. What do we know about the weights? They have to add to what? 1. And so when one of these things is x, the other one is 1 minus x. Does that make sense? And so I'm going to make, let's make the weight on debt x. So x times required return on debt, which is 7.8%, multiplied by 1 minus 0.22 is 0.78. Does that look right? So what's the weight on the other one?
1 minus x.
Yeah, 1 minus x. And that's multiplied by 10.7. Is this enough information to get you where you need to be?
10.7 be the whack.
Oh, yeah.
yeah.
It's 12, the WACC is 12.7%. You're right, it's 12%. No, the WACC is 10.7.
12%.
Yeah, there we go. Phew. Thanks for the catch there. Is that enough to get you where you need to go, or do you need me to take it further?
Is it 0.78, is it 0.078?
It's 0.78, because it's 1 minus 0.22.
Oh, okay.
That makes sense.
I was looking at the 7.8%.
Oh, that's an unfortunate coincidence.
Yeah.
There's a 7.8. And by the way, you notice I left these both in percentages? Actually, I left all three of those in percentages. As long as those are all in percentages, I'm fine. As long as they're all in decimals, I'm fine. When are they not going to be fine? If I mix that stuff up. Dr. Whitty was teaching me investments at Mizzou, and I messed those up, and he just gave me crap to no end over it. He used to be my professor. I don't know if you guys knew that. Okay. Questions? Do I have to take it any further, or have you got it? We're golden. Okay. So then the next one, number 2, she asked for. J&R Renovations, trying to determine its cost of debt. The firm has a debt issue outstanding with 18 years of maturity, is quoted at 106% of face value, to make semi-annual payments, and the coupon rate of 8% annually. What is the company's annual or pre-tax cost of debt? It's the yield to maturity on the bond. It's the yield to maturity on the bond. How are we going to figure out the yield to maturity on this bond?
TDM.
Yeah, we're going to use those. We're going to say second, clear TVM. And they're telling us this is a semi-annual bond, and it's got 18 years of maturity. What should I put in for N? Yeah, very good. So we're going to say 36N, and they're telling us that 106% of face value. What should I put in for PV? By the way, what's face value? Default. 1,000. So I'm going to put in 1,060 negative for PV. Now my coupon is 8% annually. Yeah, we've got to put in 40 because it's semi-annual coupons. And then 1,000 for the face value. I think I'm ready to compute I per Y. is that the yield to maturity?
Multiply by 2.
Yeah, you gotta multiply by 2 because this is a semi-annual number, right? And so there you go with your 7.39.182. So I'm gonna store 1 just in case everything goes horribly wrong. That's the pre-tax cost of debt, it's just the yield to maturity on the bonds. How do I find the after-tax cost of debt?
-0.88.
Yeah, multiply it by 0.78,
Yes.
which is just 1 minus 0.22. And there we go, 5.77. Does that fix you up?
Yeah.
Very good. Okay, now, number 7. Brodsky Metals has 8.2 million shares of common stock and 260,000 4% semi-annual bonds outstanding, par value $1,000 each. Common stock currently sells for $30 a share and has a beta of 1.1. The bonds have 10 years to maturity and are selling for 110% par. The market risk premium is 7%. T-bills are yielding 3%. The company's tax rate is 22%. And they're asking, first of all, what's the market value of its capital structure? How would I do that?
You gotta find the value of the equity and debt first.
Yeah. So first of all, we could say that equity is equal to, how many shares are outstanding? 8.2 million?
Yeah.
And how much is each share selling for?
30.
30. And the debt, how many bonds are outstanding?
260,000.
260,000 bonds. And what are they selling for? 110%. 110% of what?
1,000.
1,000. And so we're basically looking at 1,100 here. And so what I'm going to do is I'm going to add those together to figure out the value. Let's see. Yeah, the market value capital. Okay, so they're wanting the weights. Okay, so let's go ahead and do equity. 8.2 million times 30. I've got 246 million. I'm going to save that in location 1, store 1. I'm going to write a little 1 beside it. You'll see why here in a second. Okay, now to figure out the value of the debt, I'm going to take 260,000 and I'm going to multiply by 1,100. And I'm going to store that in location 2. The value of the firm is just the debt plus the equity. So all I've got to do is say plus recall 1 equals 532 million. Here's what I'm going to do with that number. I'm going to store it in location 3. So how do I get the weight on the equity? I'm going to say recall 1 divide by recall 3 equals. It's 0.4624, so that's the answer there. For the debt, I could take recall 2 divide by recall 3 equal. And I get the same answer that they do. Okay, now it says if they're investing in a new project that has the same risk as their typical project, what rate should you use to determine the project's cash flow? What do we use when the project is identical in risk to everything the company already does?
WACC.
Yeah, we use the WACC. So what they're asking us to do is to calculate the WACC. And they give us the information. So we're going to start figuring out required return on equity. They give us the information to do the security market line. What's the risk-free rate? 3%. Because it's the T-bills. That's always our stand-in for the risk-free rate. Plus the beta, which is 1.1, multiplied by, and in this case, did it give us the expected return on the market or the market risk premium?
Premiums.
Yeah, they give us the premium. Do we need to multiply that by 1 minus T? No, it's already in there, right? And so I think that's 7.7%. I think this is 10.7% for the required return on the equity. Let's make sure I've got that right before we move along. Yeah. Okay, now we're going to figure out the cost on that debt. And the way we're going to do that is through the yield to maturity. So we're going to say clear second, clear TVM. And let's see, what do we got? 1,000 for face value. And they're selling for 110% of par, so 1,100. Negative present value. How many years to maturity? 12. And are they semi-annual or annual? Yeah, semi-annual. Okay, so if there's 12 years to maturity, what do I put in for end? 24. Enter. Oh, no, not end. End. 24 end. Now, what do I put in for the coupon? They say they're 4% semi-annual coupon bonds. What should I put in for end? Or for payment? Sorry, payment.
Wait, why is it 12?
Okay, so someone said it was 12 years. I'm having trouble seeing here.
10 years.
What the? Why are people giving me bad numbers? So 20 is in. So 20 in. I'm going to go back and read this whole thing again. 10 years of maturity. There we go. 20 is in. Coupon rates 4%. How much is the payment? 20. Very good. And we know future value is 1,000. And we've already put in the price, and so now we're ready to compute I per Y. 1.422, is that what you get? But is that yield to maturity?
No.
No, what do I need to do?
Multiply by 2.
Multiply it by 2. And there we go. So that's going to be our required return on debt. 2.844%. Okay, now that is a pre-tax number. So we're going to have to multiply it by 1 minus T. And the tax rate was what, 22%? 0.78. So there's our after-tax amount. Now we're going to multiply it by 2 divided by 3 equals. This is what I'm getting for the debt contribution to WAC. I'm going to store that in location 4. And so then on the required return to equity, I've got 10.7 times recall 1 divided by recall 3 equals. I'm going to store that in location 5. I'm going to say recall 4 plus recall 5. And that's going to give me 6.43%. And we are off. Did anyone spot where we made the mistake? And I know, I'm trying to blow through these pretty fast, but so here we go. Let's do this one more time. Recall 1 divided by recall 3. That is the return on debt. On equity, sorry. That's the return, that's the weight on equity. I'm going to store that as number 4. And then recall 2 divided by recall 3 equals. I'm going to store that in location 5. Okay, now I'm going to take this required return on equity, recall 4 multiplied by the required return on equity, which was 10.7%. I'm getting 4.95% roughly. Are you guys getting that? It would help if you played along at home. It really would. So we're going to store that in location 7. Now the other one will be recall 5 times that 2.844, and I don't have time to go back and recalculate it at this point, or I would because of the rounding, multiplied by the 1 minus T, 0.78, equal, store 8, recall 7, plus recall 8, equal. There we go. Okay, so that's number, let's see, we've done number 2, 5, and that was number 7?
We're gonna have to find the discount rate on it again.
Yeah. Your company needs 11 million to build a new assembly line. Your target debt to equity ratio is 45. Flotation cost for new equity is 11%. Flotation cost for debt is only 8%. Your boss has decided to fund the project by borrowing money because the flotation costs are lower and the needed funds are relatively small. This person is an idiot because they're raising, they're saying, oh, we're going to do it all on debt. Remember, we said that gets you away from your target debt to equity ratio. So they're asking, what is your company's average weighted flotation cost, assuming all equity is raised externally? Remember, if you have internal equity, the flotation cost of equity is 0, but here we're going to be raising it all externally. And so what we've got is a weighted average. Let's see, the flotation cost 0 is equal to the weight on debt times the flotation cost on bonds, plus the weight on equity times the flotation cost on stocks. And we said, they're saying the debt to equity ratio is 0.45. And so the weight on debt, 0.45 is equal to the debt to equity ratio. And so TD is equal to 0.45 TE. And so the total assets there is equal to TE plus 0.45 TE. That's equal to 1.45 TE. And so when I divide both sides by T, let's see, 1.45 TE. So if I'm going to find the weight on equity, it's just 1 divided by 1.45. The TEs cancel out. So that means that for the other one, for debt to equity, it's got to be 0.45 over 1.45 because they have to add the 1. Now you could do more algebra and prove that to yourself, but that's what we've got. Okay, now what we're going to do is use that as our weights. So, weight for equity, 1 divided by 1.45 equal store 1. The weight for debt is 0.45 divided by 1.45 equal. That's going to be our weight for debt. So store 2. So we've got equity is costing us 11% plus recall 2 times recall 1 times 11. I'm going to store that in location 7. And recall 2 times 8. So I'm getting 10.0689, they say 10.07. And so we got that one right. Now, they're asking what's the true cost of building the new assembly line after taking flotation costs into account. So what we've got here is the amount that we need to raise is equal to the amount needed divided by 1 minus this weighted average flotation cost. And so we need to go out there and raise 11 million. But we're actually going to have to raise more than that because we've got this 0.1007 flotation cost thing. So here's what I'm going to do. I'm gonna go ahead and divide that by 100, get it into a decimal form, put a negative sign on it, and add 1. That's the bottom part, so I'm gonna store that in location 1. And then I'm gonna take 11, divide by, recall 1, tells us that we actually have to raise $12,231,595.09. Any questions? I think we're out of time.